Alright, you guys, so we're back on slide 16 of Similarity, Proportion, and Triangle Proofs. This one's called Similar Triangles and the Pythagorean Theorem. Well, if you do not remember the Pythagorean Theorem, oh my goodness, I'm not even sure what to say except that it's a squared plus b squared equals c squared. Alright, so let's see what is going on here. So I'm going to click on my activity. Alright, so I got a triangle here, and they gave me the coordinates. Not particularly like that I got decimal right there, but I'll deal with it. Alright. So what is the measure of angle B? Because that's the letter in the middle. So what's the measure of angle ABC in triangle ABC? And record the measurement. Really, that's all they want? Good grief, after what I just went through with that last thing. Alright, angle ABC, fine. Come up here to angle. Click on A, B, C. It's a right angle, which means that's a right triangle. It is 90 degrees. Okay, that's an easy one. Question 2. Place a point D along AC such that BD is an altitude of triangle ABC. Place a D along AC such that BD is an altitude. I need an altitude. So I gotta have an altitude here. You know, I've never done this one before. Let's see if they will have altitude on here somewhere. Altitude and height are basically just the same thing. Doesn't have one. I don't see altitude anywhere. Okay, so let's think about this then. I can't just say there's an altitude. All right, but I know altitude goes straight up and down. Well, if the distance from 0, 0 over here to get up is 9.6, then I need an ordered pair at over 9.6 up nothing. All right, so I need an ordered pair at 9.60, and they want me to call it D. So in parentheses, down here in the input, 9.60, and, well, they gave it to me as E. All right, so I know it says BD is the altitude. I wonder if I can change that. I've never tried. Can I change it? Well, I can change the order pair. I want to change the name of it. Can I change the name of it? I don't know that I can change the name of it. I don't know. I don't know. Oh, look at that. Change the name. Ha ha. Go me. Darn, I'm good. I had no idea that. I had no idea that would happen. I just went for it. Okay. So I'm not sure I can do that twice. What did I do? What did I do? I clicked on this little weird thingy here, and there it was. So I just changed it and clicked my X. All right. Hey, learned something new. All right, so there is my D. So now if I draw, they want a line or a segment? Yeah, they just want a segment. So they want a segment from B to D. So come over here, click on segment. Click on B, then D. So there's my altitude. All right. So using coordinate algebra, find and record the coordinates for D and satisfy these requirements. Explain how you derive. Oh, man. Okay, well, I did that before I even realized I had to do that. All right, so look, to get to B, the ordered pair 9.67.2. At your starting point, which is usually called the origin, you have to go over to get the first number, and then you have to go up to get the second number. Well, if I needed my new D to be right below it, then I wanted to go over but not go up anything. So I knew I had to go over the same distance, 9.6, but I didn't want to go up anything, so I knew it's going to be this number, which is 0. So 9.60. All right. So let's see. Use coordinate to find the record. So D was 9.60. And looks like, yeah, that's all I had to find. All right. Sweet. All right. Ooh, question number 3. Got lots to find here. Oh my goodness. All right. Check the box labeled show altitude in triangle ABC. No way. I could have done that to begin with. Yeah, there it is. All right. So let's see. I've got my altitude here, which lays right on top of the one that I drew. I think I did mine better. All right, so let's see. What we got to do here? Divides triangle ABC into 2 different triangles, ADB and DBDC. All right, so these are my 2 triangles we're talking about. ADB, because there's ADB, is the one on the left, and CDB is the triangle on the right. All right, so determine question 2. Measure and record the side lengths of ABC and ADB. Then measure and record the side lengths of ABC and BCD. That's a lot of work. Okay. All right, let's get to it. All right, so we got to find AC. So I'm coming under the ankle, select distance or length, and again, they want AC. So I'm going to click on A, then C, and I get a 15. All right, look, AC down here is also 15. I'm not going to do double duty here. All right, so now I got to find, let's keep going, BC. All right, so click on BC. I got a 9. So BC is a 9 here. BC is a 9 here. All right, AB. All right, click on A, then B. All right, I got a 12. So AB is 12 here. AB is 12 on the second one. All right. Which means AB is 12 on this one. Okay. So AB is 12. Have I found BD yet? BD? No, I have not. So BD is 7.2. 7.2. Do I got another BD on here? Yep, 7.2. Okay. Gotta find AD. So click on A to D. I got 9.6. So put in a 9.6. All right. What do I got next? Gotta find BC. Oh, I've already got BC. BC was 9. Right? Yeah, BC was 9. All right. And DC. I haven't gotten that one yet. D to C is 5.4. All right, so putting in 5.4. All right, so it looks like here's where I'm going to divide these to get what my scale factor is. The ratios are going to be proportional, so they're all going to be the same. All right, so I'm going to take my AC, which is 15. I'm going to divide by AB, which is 12. 15 divided by 12. 1.25. All right, 9 divided by 7.2. 1.25. Told you they're all going to be the same. 12 divided by 9.6. 1.25. Guys, scale factor is always going to be the same, y'all. The sides are proportional. Scale factor, they're all the same. All right, so same thing here. 15 divided by 9. Now, not necessarily these are going to be the same as up here. You're talking about 2 different triangles. But I guarantee you these 3 will be the same, whatever they are. So 15 divided by 9. Oh, I got a 1.6 repeating. So I'm going to round that to help myself. All right, 9 divided by 5.4. 5.4. 1.6 repeating, so 1.67. 12 divided by 7.2. And 1.6 repeating, so 1.67 just to help myself. All right, so there we are. They are proportional. These are similar figures, you guys. All right, got all of that. Question number 4. What's the relationship between the corresponding sides of ABC and ABD? What's the relationship between the corresponding sides of ABC and BDC? Oh my gosh. Y'all, if you haven't learned one thing in this lesson, you have learned it now. The sides are proportional. And I can't type it where these sides are proportional because they are the same scale factor. All right, hit submit. Proportional. Proportional. All right, question 5. All right, so let's see. Both triangle ABC and triangle ADB are right triangles. ABC and ADB are congruent. The angle. Okay, that's an angle. Can you identify another pair of congruent angles in the two triangles? Based on these angles, what can you infer about triangle ABC and ADB? Oh my gosh, they're inferring the same thing over and over and over again. Y'all are killing me. All right, fine. So, all right, so similar triangles have congruent angles. Let me say that again. Similar triangles have congruent angles. All right, so I'm looking for another pair of congruent angles. All right. So I would say angle A is probably the same thing. Probably the same thing as this little angle right there. This little B right here. All right, let me see it. So I'm going to click on the angle icon and select angle. I'm going to click on DAB to find this one. So it's 36.87. I'm betting it's the same thing as this one. This little B right here. So I'm going to click on DBC. And look at that, 36.87. Move that so you guys can see. Look at that. 36.87. All right. So I said angle DAB. Angle DAB is equal to DBC. DBC. All right. So they are the same. Based on these angles, what can you infer? Well, I can infer that the triangles are similar because we already know the proportionals, the sides are proportional. I now have got an angle, so based just on side angle side alone, these are similar triangles. So the triangles are similar because the sides are proportional and the angles are congruent. All right. Same measure, so they're congruent. Yep. Same measure. Okay. So they went a step further and said why. I did not say that, but I did say that they were proportional angles are congruent. Oh my goodness. Question 6. Okay. Well, let's see. Now select point B and move it around the screen. Fine. Move. B. Oh, C moves with it. And all my little stuff changes. Interesting. All right, I want to keep my altitude the altitude. Okay. All right, you'll see 3 check boxes appear. Did I see 3 check boxes appear? Yes, they did. I didn't even look. Check the 3 boxes to find the ratios of pair of corresponding sides in the 2 triangles. Okay. Ratios. Ooh, ratios. All right, note the change in ratios as you move B. Fix B at an arbitrary position, which I've already done, and record the ratios that you see in the table. Like, for real? Okay. So ratio of length of the hypotenuse of ABC and ADB, so the hypotenuse is 1.648, leg 1 is 1.648, leg 2 is 1.648. All right, 1 point. And just like that, I forgot what it was, 1.648. 1.648. 1.648. 1.648. Awesome. All right, so now the one in the middle, ABC, and BDC. 1.258, 1.258, 1.258. 1.258, 1.258, and 1.258. Last one. 0.764, 0.764, 0.764. 0.764. 0.764. 0.764. Alright. So no matter what where you move the D, they are end up going to be the same. So there you go. Question 6 is done. Question 7. What can you conclude about triangle ABC, ADB, and BDC? Well, they are all similar triangles. The three ratios are the same. And we've already decided the angles are congruent. Oh, I can't spell congruent. Congruent. So the three triangles are similar. All right, so that's what one little squiggly means. It means it's similar. So they're saying triangle ABC is similar to triangle ADB. In fact, they're all similar. All right, self-eval. Go me. All right, so that was slide 16. I'm not sure if we have anything else in this one to get to 21. So I might see you again in this lesson. I might see you in the next lesson. Not really sure yet.